let's talk about identifying functions which are defined by graphs and equations. Now we talked about functions where we said that you cannot have the same x with two different y values. Now if you're given the relation in terms of a graph, how do you know if it's a function or not? And for that purposes, we use what we call as the vertical line test. And basically we're saying with your vertical line test, if every vertical line intersects the graph of a relation in no more than one point, then the relation represents a function. So we have your vertical line test. So the idea is when you draw a vertical line through a graph, it should intersect at only one point for that relation to be a function. If it intersects at more than one point, then it is not a function, it is only a relation. Let's look at some examples here. Let's look at this one here. You can see that we're using the vertical line test in these examples. And your first example shows you just different points given to you, and you can see when you draw a vertical line through this point, it intersects at exactly one point. When you draw a vertical line through this point, which happens to be a y-axis, again it intersects at only one point. Same thing with these 2 points right here. The vertical line intersects the points at exactly one point. Now looking at the second example, you can see when you draw a vertical line through this ellipse here, you have the line which intersects at 2 points on the graph. So you can see that this is not a function. It should intersect at only one point. If you look at the next example, you can see how it intersects only at one point right over there, and that's why we can say this is a function. Same thing with the last graph over here. You can see that you have a vertical line that intersects the graph again at just one point, and therefore we can say this is a function. So anytime you have a shape like this, an ellipse, a circle, it's not going to be a function. You can also have something of this form. Right over here, you can see how this graph, curves like that, and the vertical line intersects your graph at 4 different points. So again, this tells you this cannot be a function. But if you had a graph of this form, and you draw your vertical line through that, it intersects the graph at only one point, and it is a function since it intersects at just one point. Now let's look at some examples here. We're using the same graphs that we used earlier for our domain, but this time we're only trying to identify if these are functions or just relations. Okay? So again, if we were to use our vertical line test, just draw a vertical line anywhere on the graph, and you will see that intersects the graph at only one point. So we can say that this is a function. If you look at our graph over here, it's a circle. And if I draw a vertical line through this circle, it's going to intersect it at 2 points, and that tells me this is not a function. Looking at our other graphs here, you can draw a vertical line through that, and you can see it intersects the graph at only 1 point, and again we can say that this graph is a function. Same thing over here. If I draw a vertical line, intersects at 1 point, that's a function. And draw a vertical line through this graph. Here it intersects the graph at 2 points, and I can say this is not a function. Okay, and again with the last one, when you draw your vertical line, it intersects the graph at 2 points, and again that tells me that this is not a function. Okay, and that's just as simple as that. When you are given relations graphically, just use the vertical line test to identify them as functions or not. Okay. Now, if we had to identify functions from their equations, what would we do? So let's look at how to identify that, looking at some examples. Okay, so we're gonna identify them as functions or relations, and then we also need to come up with the domain for each one of these equations here. So let's look at y equals 2x minus 6. Now, when you are given an equation, what you will do is take just any random value for x. But you have to make sure that that value is in the domain of your relation. Okay, so I'm using 0 for my value of x, and again if you look at this function, this is y equals 2x minus 6, which as you can see is a linear equation. Linear equation means that it's a straight line, and straight lines have a domain. And we looked at this in our previous example, have a domain of all real numbers. So your domain is going to be negative infinity to infinity, which means that I could have used any value for x. I just used 0 because it's easy to work with it. So when I substitute this value of x in my equation here, the idea is you should come up with exactly one value for y. You should not come up with two different values for y. And in this example, you can see when I used one value for x, I come out with exactly one value for y. And so that tells me that this equation or this relation is a function. And that's what we're looking for. Okay? Let's look at another example here. Let's say we have y equals x to the third. So let's go ahead and identify our domain here first. Now as you can see, we don't have any restrictions here. There's no x in the denominator, and there is no even root here. So that tells us again that our domain is going to be all real numbers, which will be negative infinity to positive infinity again. And that tells me again I can use any value for x. In this case, let's go ahead and use x equals 2. So when I substitute this value into my equation here, I will end up with y equals 2 to the third, which will give me y equals 8. And again, you can see that we ended up with exactly one value for y when we use just one given value for x. And again, that tells me this function, this relation here is a function. So this is a function. The earlier example we saw, a linear equation, was also a function. All right, let's look at a couple more examples to see what would happen if it weren't a function. Now here we have the example x equals y to the fourth, or you can write it as y to the fourth equals x. Either way, it's the same equation. Now, the idea is, what's our domain going to be? What's our range going to be? I'm sorry, what's our domain, and is this a function, or is this just a relation? So to find out, what you will do is, let's see, we could go ahead and solve this, try to get y by itself and move the x, get rid of that y to the fourth over there. To do that, I will go ahead and take the fourth root on both sides. The fourth root will cancel out the fourth power, and you will end up with y equals fourth root of x. And as you can see, we have an even root here, and as we talked about this earlier, even roots cannot have a negative value inside, for their x here. So that tells me my domain will be again a restricted domain, which tells me it has to be either 0 or positive numbers. So your domain will be 0 to infinity, including 0. All right, now that we have our domain, let's go back to our original function here. Go back to our original equation here and try and figure out, is this a function or is it not? So you have x equals y to the fourth. Let's say x equals, no, I think it'll work better if we use actually a value for y, okay? Let's say y equals, I don't know, let's just use 1, okay? So when you have y equals 1, you will have 1 to the fourth, which will be x equals 1. If you use y equals negative 1, okay? And you will see what happens when you use y equals negative 1. When you take x equals negative 1 to the fourth, and again we're just plugging it into our original equation here, negative 1 to the fourth will also give you positive 1. So what you have here basically is, for the same value of x, you have two different values of y, and right there we know this cannot be a function. You cannot have two different values for y for a given value of x, okay? So right there we have concluded that this equation is not a function, it is just a relation, okay? So you have to be careful when you're working with these functions. I want to look at one last example. And this one is y equals 2 over x minus 9. Okay. In this example, you can see that you have x in the denominator, but this time x is not by itself. You have x minus 9. Now again, remember, as we did earlier on, you cannot have a 0 in your denominator, which tells me x minus 9 must not equal 0, because that's when my y will be undefined. So first of all, we'll go ahead and take our denominator and set it equal to 0. What we are trying to do here is we're trying to find the value for which the denominator will be 0. So when you solve this equation, you will end up with x equals 9. And you can see that when you do x equals 9, you substitute it here, 9 minus 9 gives you 0. Okay, and we don't want it to be 0, so that tells me we need to exclude 9 from our domain here, because when 9 is part of my domain, that's when my denominator is 0 and I cannot use 0 in the denominator. Okay, so in this case your domain, now 0 is not going to make a difference to us, because when I put 0 for x, you get 0 minus 9, which is negative 9, so that does not make my denominator 0. I'm okay with using 0. The only time, or the only number that I cannot use in my domain is going to be 9, because 9 minus 9 gives me 0, and I don't want 0 as part of my denominator. So in this case, your domain will be from negative infinity to 9, and then from 9 to positive infinity. And again, you can see we are not including 9 by using parentheses around it, and then we'll use the union to join the two halves. So again, on our x-axis here, you can see we're just saying that everything else is okay to use except 9. We don't want to include 9, and everything else is fine. And there you have it. That's your domain. Now, we need to try and decide, is this a function or is this just a relation? So y equals 2 over x minus 9. Now, except 9, we can use any other value for x here. So how about, I don't know, let's say 11. Okay, and the only reason I'm using 11 is because it'll be easy to work with it. So let's substitute for x in our equation. That will be 11 minus 9. You will see that will give you 2 over 11 minus 9 is 2, which gives you y equals 1. So for one given value of x, you come up with just one value of y. And that right there tells you that this equation is a function. Alrighty, so that concludes our discussion about how to identify functions defined by graphs and equations. Yeah. All right. Let's talk about, do I have enough tape?
Should have. Let's see here. Darn teacher sitting on the edge of their seat. Well, you got 17 minutes left. Hang on, your tape.
I think
Tape out.
maybe, yeah.
I'm winded.